Hello, my amazing Algebra 1 students. This is Mrs. A, and I love math. Today we're talking about lesson 3 of our Saxon orange book there. And we're talking about some pretty interesting concepts. And the first one that we're going to talk about is perimeter. So when we're talking about perimeter, we're talking about peri means around in Greek, and metron means measure in Greek, and these are the two parts that make up perimeter. So perimeter means to measure around. And we have a very cool problem here, but I want you to be careful because notice that there are some numbers missing. We're going to assume, I'm not the best artist, but we're going to assume that all the lines are straight. And we're going to assume that all of the angles are right angles. So just pretend that everywhere you can that there's a little right angle there, just like we talked about before. Everything is right, okay, and they're all straight. So now we're supposed to find the perimeter or the distance around this figure. Do you see something missing? Okay, so we've got a measure here and here and here is 15, but what about right over here? There's something missing. Can you look at the figure and decide what it should be? Okay, these heights are supposed to be the same. They have to be the same because notice this is 5 and this is 5 over here. That means that these two must be at the same height, even though this kind of looks a little bit crooked here because I'm not the best artist or the most accurate drawer, okay? So we're going to say they are the same height, and therefore, shouldn't this one over here be 9, just like this one that matches it is 9? So we took care of one missing number. Can you see another missing number on this board? What about this one right down here? This 15 goes with this bottom line, which is wider. How can we find out what this line across, kind of like the two legs here, going up here and up here. So this line's between the two legs, and how do we figure out what that is? Well, we know this bottom line is 15, and we know everything is right, and we know this top of this one measures 4, and this top measures 3. So if we took 15 minus 4 minus 3, we would get this distance here. So 4 plus 3 is 7. 15 take away 7 is 8. So now, do we have every part of the figure labeled? Once we have every part of the figure labeled, then it's not very difficult to add all of them up. So this one is in your book. We're going to add up 9 plus 4 plus 5 plus 8 plus 5 plus 3 plus 9 plus 15. And when we add those all up together, your book says we get 58 inches. So let's believe the book. 58 inches. I would suggest you do it yourself just to make sure. So now we're going to walk down to the bottom of the page and we're going to talk about circumference. And we're on 3B right now, and we're on page 10 if you're trying to follow me in the book. So we're talking about circumference, which is the distance around a circle. And here we have some terms that we need to know. So a circle, so I've drawn something that looks kind of like a wagon wheel, but a circle is the path of the points that is equidistant from the center. We call that distance that each one of these wagon spokes is equal to. We call that distance the R, or the radius. And the radius is the distance of each point on the circle from the center. Now we have some terms we have to learn about circles. Okay, this right here we just talked about was the radius from the center to the edge of the circle, And it can be anywhere in the circle. In fact, there's an infinite number of radii or radiuses in a circle, because a radius could go to each point. It's just the measure of the distance from the center to the circle. So you could draw a radius anywhere. And then the diameter, again, you could draw it anywhere, because it is any line that goes exactly through the center of the circle and touches both ends. So I could draw a radius here, a diameter there, and I could draw a diameter here, and I could draw a diameter here. And wouldn't it be true that a diameter is going to be twice the radius? Because the radius only goes halfway across, and a diameter goes all the way across. Now, in red over here, I've got a very cool word, circumference. And circumference is written all the way around like that because it is the distance around a circle. So now we have, when the ancient Greeks were trying to figure out a circle, okay, I'm sure they had their share of wagon wheels that they had to deal with, but they started to do a little bit of math, and they said, how do we figure out this circumference of the circle? And they found that a relationship was always true, that if they took a string and they measured the diameter of the circle, and then they took that string, the same measure as the diameter of the circle, and they wrapped that string around the circle, it would go 3.14, lost my marker there, 3.14 times. Okay, 3 and a little bit. So they came up with a formula. And the formula is that the circumference of the circle is pi, which is that number, 3.14, but exactly the measure. This is approximately the measure, but this one is exact. And we're going to talk about pi some more in a minute. Pi times the diameter would equal the circumference of the circle. So this number pi has become very famous in mathematics because it is the ratio of the diameter, the circumference divided by pi is the diameter, and the diameter times pi is the circumference. So since we know that the diameter is 2 pi, then we could also express the circumference as 2 pi r. So you're going to have two different ways that you can learn the circumference formula. Circumference is pi d, and circumference is 2 pi r. Now in our book, we're going to use 3.14 as an approximation for this number pi. This number pi is what we call an irrational number because it goes on and on and on forever and ever, amen, and never stops. It never repeats, and that is an irrational number, which we will learn more and more about. But right now, we'll talk about rational and irrational later. But right now, pi is an irrational number. It is the number that you would get if you divided the circumference of the circle by the diameter of the circle. You would get the number pi. And the Greeks saw it come up so much that they decided to name that number pi. So pi is the number of times the diameter will wrap around the circumference, but we use an approximation for pi, which is 3.14. And that's not exact, but we're going to say pi is approximately 3.14. For our purposes, that's close enough, but you must know that it's not exactly how many times the diameter will wrap. Their circumference is the distance around the circle, and it is equal to pi d or 2 pi r. I lost my r there. So here we have again, pi is irrational. It is 3.141592654 ... and it goes on forever. And we will use 3.14 to approximate. And here are two formulas that you must memorize. Circumference is pi d, and circumference is 2 pi r. So let's work a problem. We have the radius is 3. What is the circumference? Circumference is question mark. So since we have the radius, let's use the radius formula. The circumference is 2 pi r. Okay, so we're going to put the r, which is 3, right here in place of the 3. And in place of the pi, we're going to put its approximation, which will be 3.14. So the 2 times the 3, remember multiplication is commutative, and commutative means I can do it in any order. So I don't have to keep these separated. 2 times 3 is 6. So we have 6 pi, which is 6 times 3.14. Now I'm going to do the math. So we're going to come up here, 3.14 times 6. 4 times 6 is 24. Carry the 2. 1 times 6 is 6 plus 2 is 8. 3 is going to be 18. And then I'm going to put my decimal 2 places in. And my circumference is approximately 18.84. And that is the correct answer. I'm trying to get my little glare out of there. All right, let's do another one. We have circumference is 24. What is r? Okay, well, circumference, we know circumference is 2 pi r. So if we wanted to solve for r, could we divide by 2 pi on this side and divide by 2 pi on this side? We could. Okay, so we know what the circumference is. The circumference is 24. So when those two, the 2 and the pi cancel, and I would be left with r, and r is what I'm trying to find. So here is the math that I'm going to do. Circumference divided by 2 pi will give me my r. So circumference is 24 divided by 2 pi. So that's going to be 2 times 3.14 is our approximation. So now I need to do that math. Now, is there a way I could do it easier? Could I go ahead and do the 24 divided by 2 first and get 12 divided by 3.14? I could. 12 divided by 3.14. So I can always simplify before I do my division. So let's do 12 divided by 3.14. It's always good to do a little bit of long division to review. Okay, so I hope that you don't get too dependent on using a calculator, because calculators really in the long run make your brain not work quite right. So I want you to do as much work as you can without your calculator, because so many students today are losing their ability to do long division because they're always going to the calculator. So parents and teachers, let the calculator be minimal use. Only when you absolutely have to, or maybe after a long hard day when there's just no other way around it. But as a general rule, let's don't use the calculator, not this early in mathematics. The students are still learning their basic skills. So here we have, what do we do when we have a decimal in our divisor? Don't we have to move that decimal 2 places to the right? And our understood decimal here has to also be moved 2 places to the right. Okay, so 314 into 1200 is our new problem. So now we're going to approximate, which I've learned that many students have forgotten how to do. but 3 goes into 12 4 times, but we've got something left over, so we're going to say 3 times. So 314 would go into 1200 3 times. So we're going to put the 3. 3 times 4 is 12. 3 times 1 is 3 plus 1 is 4. 3 times 3 is 9. And now we're going to subtract, and we're going to get to practice our borrowing too. So we're going to come over here. We can't do that. We're going to come all the way over here, take away the 2, make it a 1. Bring the 10 over here, cancel, make it a 9. Bring over the 1. 10 take away 2 is 8. 9 take away 4 is 5. And now we've got 1 take away 9. We're going to have to come over here and borrow again. 11 take away 9 is 2. And there's nothing left over there. So now we're going to bring down a 0, because this is now our decimals here. We can bring down a 0 and carry it out some more. And 314, now our approximate is going to be into 25. So we're going to say that's going to go into there. I'm going to guess 7 here. So we're going to say approximately 7 times, because 3 into 25 would go 8 times, but I've got this little 14 here. So let's try 7. 7 times 4 is 28. So we'll put down the 8, carry the 2. 7 times 1 is 7 plus 2 is 9. 7 times 3 is 21. Okay, so let's see if I guessed low or if I guessed okay. So now we're going to subtract, and we've got the, make that a 7. 10 take away 8 is 2. And then we're going to have to borrow again, so we come over here, make that a 4. 17 take away 9 is 8. 4 take away 1 is 3. And you know what? We guessed too low, didn't we? So I should have made that an 8, guys. Sorry about that. Sometimes I guess right, sometimes I guess low. So we're going to have to redo. Okay, so 8 times 4 is 32. And 8 times 1 is 8 plus 3 is 11. And 8 times 3 is 24 plus 1 is 25. And that's what I should have done to start with. And so this is going to be 68. So I have 68 over that left. Okay, so remember our decimals right there. Okay, so 3.8, and we can carry it out one more. Let's do that. Let's carry it one more time. So we're going to say, put one more 0 there, and that's going to definitely go in there twice. So it'll be 3.82. And I didn't leave enough on my board to show all the work, but 3.82 is your answer. I just love this type of problem. We're looking at example 3.4 now, and this is on page 12 of your book. This is kind of a long lesson, but we're learning some really cool things. So now that we've learned about how to find a perimeter, and we've learned about how to find a circumference, now we're going to find the perimeter of this figure. Now notice that this figure is made up of a rectangle and a semicircle. A semicircle is a half of a circle. So let's think about this a minute. If we were going to look first and say, do we have any missing pieces that we can figure out, given the good brain that God gave us? Okay, we have a 10 here, and doesn't this one up here have to be a 10? Because everything is right, everything is straight, so we're going to say this one up here must be a 10. Well, we don't have this one here, but do we? We know that this radius is 3, and this radius is going to come up, and it's going to be right here and right here. So this whole side is 6, because this little half circle is exactly a half circle. It's probably drawn a little bit too flat here. Make it go out just a little bit more. Look more like a half circle. But this is 3, and this is 3. because the radius is 3 and it would lay down both directions. So this whole side is 6. So the width is 6 and the length is 10. And then we have 3 parts of our circumference, but now we have to figure out what is this distance around the half circle. Well, if the circumference is 2 pi r, but we're looking for half of a circumference, wouldn't the half circle have a circumference of just pi r? Wouldn't we just divide that by 2? So this right here is going to be pi times 3, or 3 pi. Okay, so we'll put the 3 in front. Looks better. 3 pi. So now, isn't our perimeter going to be 3 pi plus 10 plus 6 plus 10? Well, the 10 and the 10 and the 6, that's easy. That's 26. So we have 26 plus 3 times, because the radius was 3. Okay, so the half circle is going to be pi r, and so that's pi times 3. So remember, pi is 3.14 approximately. So now when I multiply 3 times 3.14, won't I get 3 times 4 is 12, carry the 1, 3 times 1 is 3 plus 1 is 4. I will get 9.42 plus 26 is going to be, when I add the whole parts together, 35.42. And 35.42 is the answer. So this was all in inches. So of course we should put inches in our answer. And that is your first example there. Now this one is fun. This is example 3.5 on page 12, and they gave us all sorts of cool mysteries to solve. Okay, so we have some missing numbers here. Can we figure them out? So first of all, we have a missing length, we have a missing width on both sides, but we do know that we have a semicircle, and we have this little piece here that says 6. So, do we know something about this length here because of this semicircle that has a radius of 4? Won't that radius swing down here and lay down here and then lay down here? So isn't this going to be 4 and 4? So altogether, won't that part be 8? Okay, so we have 8 plus 6 is 14. So this one over here must be 14. Okay, so now we've got to figure out what this is. Well, this one over here is a semicircle that has a radius of 5, and that radius would lay down here and here, so 5 and 5 is 10, so this side is 10. Now, when we're doing these perimeters, we're not paying any attention to this line or this line, because remember, we're just doing distance around. They make those lines in your figure, they make those dotted lines, dashed lines, just to show you that, hey, that line's really not there. It's just helping you to see that that is a semicircle. Okay, so what we're trying to do for our circumference is we're trying to add this line, this curve, this line, this line, this curve, and that would be the perimeter. Did I say circumference? Perimeter, because it's the distance around. It's got some semicircles, but it's the distance around a figure that's not a circle. So we would call the whole thing the perimeter. So let's see what we know. We know the 6. We know the 10. We know the 14. Okay, we know how to find the half circle because the circumference is 2 pi r. The half circle, we'll call it HC, the half circle circumference is going to be half of that, so pi r. Okay, so r is 4 pi. So we'll say 4 pi plus, and then this one is going to be pi r, or 5 pi. Now I'm going to make this easy on myself. I'm not going to do 2 multiplications when I can do 1. So 4 pi plus 5 pi is 9 pi. So we have 9 pi. And then 6 and 14 gives me 20, plus 10 more is 30. So now all I have to do is 1 multiplication. 3.14 times 9 is going to be 36. 9, 10, 11, 12. 3 times 9 is 27, plus 1, 28. Almost made a bad mistake. And then 2 decimal places. So 28.26 plus the 30 is going to be 58.26. And all of those were in feet. So that will be your answer. Okay, so that is example 3.5 in your book worked out for you. Let's look at your practices. We have practice A through E that I'm going to help you with. The first one says that you have a length of 10 and a width of 5 on a rectangle. What is the perimeter? Well, all we have to do here is fill in the missing parts here. We have 10, so this one down here must be 10. 5 on the left must equal 5 on the right because it's a rectangle. So we have 10 plus 10 is 20, plus another 10 is 30. So the perimeter is 30 for practice A. Practice B tells us we have a square that has a perimeter of 12. Now we know something about a square, and that is that it has 4 sides the same. So if the whole distance around is 12, wouldn't I divide the 12 by 4 equal sides? Remember those little tick marks there? 4 equal sides to get the length of one side. So 12 divided by 4 is 3, and if we added 3 plus 3 plus 3 plus 3, we would get 12, or 3 times 4 is 12. So the side length of the square is 3. All right, so this one is C, and it has one of those little castle shapes again. And remember, even though I'm not such a great artist, each one of these is right angles and straight sides. Okay, so we have a 5 and a 5. They didn't leave that a mystery. We have a 12 on the bottom, but they left this part right here a mystery. They have a 2 and a 2. They did not put this one here, but it looks like, at least in the picture, it looks like it's the same height here, so we're going to give this a 2. And then what about this distance here in between? So we know this right here is 2, and this right here is 4, and this whole thing down here is 12. So doesn't the 2 plus the 4 equal 6? So 12 take away the 6 must be that. So 2 plus 6 plus 4 is 12. So now we've got all the parts. So now we would add them all together. So let's go all the way around. Let's start with 5. Okay, 5 plus 2 is 7, plus 2 is 9, plus 6 is 15, plus 2 is 17, plus 4 is 21, plus 5 is 26, plus 12 is 38. The last 2 problems are very easy. We have on D, they give us the radius and they ask us to determine the circumference. Well, we know circumference is 2 pi r, which is 2 pi times 5, which is 10 pi. And we don't even need to worry about that one. What do we know when we multiply by 10? The pi is 3.14, but when we multiply by 10, don't we just move the decimal one place to the right, and we can skip all of that multiplication? So we're going to move the decimal one place to the right and get 31.4, and that is certainly an easy way to do that one, isn't it? Okay, and then we have something that looks like a square on E, but we don't know it's a square till we look over here and we see our radius is 3. Since our radius is 3, that means this side is 3 plus 3, which is 6. So since I have 6 here and 6 here, it is a square. So that means this is 6 and this is 6. And we have all the parts except we need to figure out this distance around, which is half the circumference of a circle. Since circumference is 2 pi r, then half of a circumference is going to equal just pi r. So since 3 is our r, we're going to have this distance around be 3 pi. So now let's do the math. 6 plus 6 plus 6. Remember, this side right here is dashed. We don't add that one in. So 6 plus 6 plus 6 is 18. And then 3 times pi is 3 times 3.14, which is going to be 949.42. So we're going to add 9.42. And when we add it all together, we're going to get 27.42. And that is the end of Lesson 3 in your Orange Book. And this is Mrs. A, and may God bless your day.